Question. DS. For positive integers m and n, what is the greatest common divisor of m minus 1 and n plus 1? Condition 1. M equals 2. Condition 2. N equals 4. Solution. Let us solve this DS question using the variable approach. Definition of factors and multiples. Factors of a number, say p, are the integers which can divide into p without a remainder. A multiple of a number, say m, is an integer p which can be obtained when m multiplies with another integer, say n. That is, if we have a number p such that p equals m times n, and m, n, and p are integers, then m and n are factors of p, and p is a multiple of both m and n. Let's apply 3 steps of the variable approach. Let us follow the first step of the variable approach by modifying and rechecking the original condition and the question. We are required to find the greatest common divisor of m minus 1 and n plus 1 if m and n are positive integers. Follow the second and the third steps. From the original condition, we have 2 variables, m and n. To match the number of variables with the number of equations, we need 2 equations. Since conditions 1 and 2 will provide 1 equation each, C would most likely be the answer. Recall 3 principles and choose C as the most likely answer. Let us take a look at both conditions together. When we take the 2 conditions combined, we get m equals 2, which gives m minus 1 equals 2 minus 1 equals 1, and n equals 4, which gives n plus 1 equals 4 plus 1 equals 5. Thus, the greatest common divisor of m minus 1 and n plus 1, which is GCD 1, 5, will be 1. The answer is unique, and conditions 1 and 2 combined are sufficient by CMT2, which states that the number of answers must be 1. Thus, C seems to be the answer. However, since this question is an integer question, which is also one of the key questions, also by tip 4, which says that the trivial condition usually is not the answer, that is, C is not the answer, we should apply CMT4A, which means that when answer C is found too easily, either A or B should be considered as an answer. So let us check each condition separately. Condition 1 tells us that m equals 2. Thus m minus 1 equals 2 minus 1 or 1. Since one of the numbers is 1, the GCD m minus 1, n plus 1 equals GCD 1, n plus 1 will always be 1, irrespective of the value of the other number. This condition has a unique answer, so this condition is sufficient by CMT2, which states that the number of answers must be 1. Condition 2 tells us that n equals 4, thus n plus 1 equals 4 plus 1 or 5. But we do not know the value of m. When m equals 2 and n equals 4, the GCD m minus 1, n plus 1 equals GCD 2 minus 1, 4 plus 1 equals GCD 1, 5 equals 1. However, when m equals 6 and n equals 4, the GCD m minus 1, n plus 1 equals GCD 6 minus 1, 4 plus 1 equals GCD 5, 5 equals 5. Since the values of the GCD m minus 1, n plus 1 are not unique, this condition is not sufficient by CMT2, which states the number of answers must be 1. If the question has both C and A as its answer, then C is the answer rather than C by the definition of DS questions. Also, this question is a 50/51 level question and can be solved by using the relationship between the variable approach and common mistake type 3 and 4, A or B. Condition 1 alone is sufficient. This is a 50/51 level question. You should be careful when solving an integer question with answer C. About 4 of these questions appear in the exam. Thus, A is the correct answer. Answer A.